Everyone, this is a quick tutorial on how to use the stoichiometry gizmo. So the first thing that you're going to do is you're going to click on this link right here, the stoichiometry lab link, and that's going to bring you to this right here. I recommend you splitting your screen so that you can work from the gizmo and then type in your answers on the screen at the same time. So you're going to launch your gizmo. Make sure that you are logged into the system so that you don't get logged out after 5 minutes through Gizmo. So the first thing that you're going to do is you're going to answer the pre-lab questions. The pre-lab questions are really to kind of get you in the thought process of what's going on in stoichiometry. So the examples that are used here are basically with recipes. If you like to cook and sometimes you need to cook for more people or for fewer people, you need to scale your recipes. So you need to multiply the ingredients by a certain amount, or you need to divide by a certain amount. So these questions are kind of going into the same idea. Stoichiometry does the same thing. We're multiplying or dividing our reactants to get a certain amount of products. So with the Gizmo warm-up, what you are expected to do is you are expected to look at this first equation. And when you're looking at the equation, you're expected to write down the coefficients. So the coefficients are the numbers that are in front of each of the components of a chemical reaction. So right here, your coefficient would be 1, because 1 we don't write just because it's very redundant. Here you would have a 3. So you would look at the coefficients and then fill in those numbers right here. Then it says in a balanced chemical equation, the same number of each kind of atom is shown on each side. So we're practicing balancing. So what I would like for you to do is take a look at how many ions do you have on the left side, the reactants, and how many do you have on the products. Now, the one for iron is done for you to give you an example of what that should look like. I have 2 irons here and I have 2 irons there. So you're going to fill in the answers for oxygen and carbon and answer these questions. The next thing that you're going to do is you're going to be looking at a review of molar mass. So in molar mass, you did a lot of this in previous lessons. You're looking at the molecular mass first. The molecular mass is basically the sum of the masses of all of the different atoms or elements that are in a molecule. And the molecular mass is the mass of that one single individual molecule. When we move on to the molar mass, the value is exactly the same, but what we're looking at is we're looking at the number of grams per 1 mole of that substance. So you're going to calculate the molar mass of Fe2O3, CO, Fe, and CO2, and then you're going to check your results over here on your tiles, okay? The next thing that you're going to do is you're going to practice dimensional analysis. So the first one kind of walks you through how to do stoichiometry problems. And then you're going to continue that with some more examples. So right here, we're looking at 2 moles of carbon monoxide, and we want to go to grams of carbon monoxide here. Right here, we're looking at, it says the first question, how many moles of carbon monoxide are required to react completely with 1.75 moles of iron 3 oxide? So I have 1.75 moles of iron 3 oxide, and I want to convert that to carbon monoxide. So my starting unit is going to be moles of iron 3 oxide, and then I'm going to moles of carbon monoxide. So I'm going to find a fraction that has both of those. This fraction right here has both carbon monoxide and iron 3 oxide. And I can go ahead and look at my units, and my units show me iron 3 oxide, divided by moles of carbon monoxide. So that's not going to work because nothing canceled here. But if I flipped the tile, by flipping the tile, you see that moles are going to cancel at moles of iron 3 oxide, and you get moles of carbon monoxide. Then you want to go ahead and calculate 1.75 times 3 divided by 1, and then check your numerical answer right here, okay? Now, following that, you're going to move on to some more practice problems. So you're going to flip through these different questions. So flip through new question, and I'm going to go to until I see 2.90 moles of iron. So 2.90 moles of iron. So I'm going to keep flipping through. And right there, I have 2.90 moles of iron, and I'm figuring out the volume of carbon dioxide. And that is the question that I have right here. So you're going to go ahead and answer this question. You're going to drag and drop your tiles, and you're going to check your answers here. Okay. You're going to do that for A, B, C, and D. So for this specific equation. Now, this very last part, what you're going to do is you're going to choose a new equation. And a new equation is going to end up giving you a new question. So I might try to solve this question. And it says, what mass of calcium chloride would be produced in reaction of 125 grams of hydrochloric acid with excess calcium hydroxide? That just means that I have more than enough calcium hydroxide, so I don't have to worry about that limiting my reaction. And we're going to talk about that in future lessons. So 125 grams of hydrochloric acid. I want to convert from grams of hydrochloric acid to moles. So I'm going to look for hydrochloric acid, which is HCl. Okay. And then I want to convert from moles of hydrochloric acid to moles of calcium chloride, because I can't just go to mass of calcium chloride because it's not an even trade. It's not an even switch. So I'm going to go to moles of calcium chloride. Now, if I check my units aren't going to cancel. So I need to flip that tile. And now my units cancel. And then finally, I want to go to my mass of calcium chloride. So I need to find my mass of calcium chloride, move that over here, and I'm going to need to flip my tile to make sure everything cancels. When I show my numerical result, I would also like for you to calculate these in your calculator. So 125.9 divided by 36.46 times 1 divided by 2 times 110.98, and then show your numerical result. Then what you're going to do with this is you're going to take a screenshot. So I have my Windows Shift and S, and I'm going to take a screenshot of this image right here. And then I'm going to go ahead and embed that into my assignment right here. So I'm going to copy that right there so then I can see that you did your work. Okay. If you have any questions, please make sure that you reach out, and hopefully this was helpful.